Hey Mustangs, it's Miss Sigmund here, ready to work you through lesson 5-1. We're going to talk about perpendicular and angle bisectors. Make sure you have your notes out and your pencil ready and you're good to go. Here we go. The first two theorems work together. It's the perpendicular bisector theorem and its converse. So it's going to work forwards and backwards. So if we're given a scenario like this picture where we have a line that's going to cut a line segment in half, and we see those congruent tick marks there, so we know that this line x to q is the same length as y to q, and we also have this box in the corner which represents that 90-degree angle, so we know that PQ is a perpendicular bisector of xy, and if that happens, then these hypotenuses on the outside of those triangles there, those are going to be equal to each other. Okay, and it also works the other way. It says if these two things are equal to each other, if the two hypotenuse are equal, then I know that point P is on the perpendicular bisector. So here, have it dived in a little bit closer so that we can take a look at this and we can see what's really happening. So what I've got for you here is I've got these two triangles, and we've been doing congruency with triangles in topic 4. Lesson 4-3 and 4-4 and 4-5 went through those different theorems for triangle congruency. And so what we've got here is we have the reflexive property popping out at us. So PQ is congruent to itself here. So I just put the tick marks on to show that it's congruent to itself. And what we have is a right angle that comes across, because if this is 90 degrees, then this has to be 90 degrees. It's a linear pair, and that's going to come from topic 2 on all those angle pair relationships. Everything in math builds on itself, and so here's where it's going to come in handy. So what we see here is we see these two triangles, and they are in fact congruent by side angle side congruency. And so we have those two triangles, and we can say, okay, if I have two triangles that are congruent, then that means that they are exactly the same in all ways. And all the line segments and all the angles are going to be the same measure. So that leaves us with the property of CP/CTC, corresponding parts of congruent triangles are congruent, and that means that this long line P to Y is going to be congruent to P to X. So kind of just a quick proof of that theorem. And another way to look at it would be anytime we have a triangle drawn on here, so this blue line here would be congruent to this blue segment over here, red would be congruent to red, and yellow congruent to yellow. So we can put a point anywhere on this perpendicular bisector, and it will create two congruent triangles off of it. So let's apply it with a couple examples here. The question I have for you is, what is the measure of MN? So M is here on the perpendicular bisector, and it goes down to N. This is going to follow very nicely with the picture from theorem 5-1, right? So what I've got is these two tick marks, which means that this bottom side is 3 and this side is 3. We have M on the perpendicular bisector. Therefore, MO is congruent to MN, and it makes MN equal to 7. Pretty straightforward there. As we move forward here, now we're going to apply algebra to that theorem and to those triangles that we know more about now. So what we're looking at here is we're looking at this triangle, and it has a perpendicular line down from A to C, and we have to say, well, is it a bisector? Because we have to have a perpendicular bisector in order for these two things to be congruent. And sure enough, 11 is congruent to 11. These are the same length line segments, so theorem 5-1 holds. If this is a perpendicular bisector, then AB is going to be congruent to AD. So now we can do the algebra. We can say, okay, 6x minus 10 is equal to 3x plus 2. We're going to work our way through by combining like terms. The first thing I chose to do would be to subtract 3x from each side, because that would be the opposite of positive 3x would be negative 3x, and it makes that nice zero pair, and is going to bring it over here to combine like terms. So we're going to end with 3x minus 10 is equal to 2. And then what am I going to do next? Well, I'm going to say, what is the zero pair that will match up with negative 10 or minus 10? And whatever I do to this side, I've got to do to the other side too. So the zero pair, the thing that will match, will be a positive 10. So I'll add 10 to each side, and I'll get 3x is equal to 12. And then I say, well, self, I don't want to know what 3 x's are equal to. I want to know what 1 x is equal to. And so I say, okay, what do I need to do to this 3 to make it a 1? Well, if I divide it by itself, if I divide by 3, 3 divided by 3 is 1. Whatever I do to one side, I have to do to the other to keep the equation balanced. And I'm left with 12 divided by 3, which is 4. So x is equal to 4. The fun's not done yet, my friends, because we solved for x, but that question wanted us to solve for AD. So what I need to do next is take that 4 and plug it into the equation and solve for AD. So 3 times 4 is 12, plus 2 is 14. AD is equal to 14. Okay, so the next problem asks us to find the value of WY. So now we're going to use the converse of the perpendicular bisector theorem. We're working our way backwards. The picture tells us that XZ is congruent to YZ, and here we have a perpendicular line. So the converse of the perpendicular bisector theorem tells us that if these two hypotenuses are equal to one another, then these two line segments are also equal. So XW will be congruent to YW, and now we can do some algebra and set those two guys equal to each other. We can say 5n minus 2 is equal to 2n plus 7. Go ahead and pause the video, give it a shot, and work your way through that algebra here in the next couple minutes. So hopefully you had a chance to do that, and you can check your answer along with me. So the first thing I chose to do was to subtract 2n from both sides. Not the only option to start with, so there was actually 4 different things you could have done right there. But I chose to subtract 2n from each side. And that left me with 3n minus 2 is equal to 7. And then I said, okay, self, I'm ready to find the 0 pair for minus 2, and that would be a plus 2. So I'm going to add plus 2 to both sides. And then I'm going to say 3n is equal to 9. And I'll say, okay, if 3 n's equal 9, then 1n must equal 3. So divide both sides by the coefficient in front of the variable. 9 divided by 3 is 3. All right, but the fun's not done. We solved for the variable, and we need to plug it back into the equation. Do some plug and chug. And we want to know the value of WY. So 2 times 3 plus 7 will give me 6 plus 7, which is 13. So my answer, WY is equal to 13. This last one, go ahead and give it a shot. Pause the video. And the question is, what is the value of OL? This one's really similar to the last one where we use the converse of the perpendicular bisector theorem. We want to find the length of this tealish line down here. So give it a shot. Okay, here's what I did. I said, okay, this big triangle on the top, fits the theorem 5-2, and it says, well, this length, KL, is congruent to LK, and there's a perpendicular line. So if this guy's 14, then from N to L, that also has to be 14. So it's 14 there. And then, okay, self, this triangle here on the bottom, MNL, it also fits the profile for theorem 5-2, the converse of the perpendicular bisector theorem. 9 is congruent to 9. We have that perpendicular line. And I can say that those two pieces there from N to O and from L to O are going to be congruent. And I'm going to do 14 divided by 2 will give me 7. And OL is equal to 7. That's my answer. Okay, the next theorem we're going to look at is the angle bisector theorem, and this is 5-3, and its converse is 5-4. So got that picture there, and what we're saying is if a line is an angle bisector, then it is any point on this line on the angle bisector is equidistant from the sides of that angle, and vice versa. So let's do a couple examples. Here in this first one, I'm going to tell you that HI is 7, IJ is also 7, and the measure of HGI is 25 degrees. Okay, so in this case, if it's the converse, it says these two things are equidistant. Okay, what's the measure of this angle down here? And we're saying, okay, so if these two lines are equidistant and they're the same measure, then this must be on the angle bisector. And if this is 25 on an angle bisector, then this other angle also has to be 25 degrees. So 25, 25, 7, 7. Okay, the next one is working our way through the angle bisector theorem, theorem 5-3 forwards. So what it gives us this angle is 57, and then it gives us the half angle is 28.5 degrees. So if this is an angle bisector, then these two pieces will be the same. So check it. Is 57 divided by 2 28.5? Yes, it is. So we know that GI is the angle bisector, and therefore HI and JI are going to be the same measure. So IJ would have to be equal to 12.2 over here. This is 12.2. This also has to be 12.2. Okay, go ahead and give this one a shot. This is going to be theorem 5-3, the angle bisector theorem. These angle marks tell us that these two angles are the same measure. Therefore, this is an angle bisector. And here's what we're going to do. We're going to say, well, LO and M and NO are the same length. So set up an equation and solve for x in this figure. Hopefully you had a chance to do that. And so here's what I said. 4x minus 5 is equal to 23. There's no x on the right side of that equation to combine to the 4x, so I'm just going to jump to this 5. What's the zero pair for negative 5? Well, it's positive 5, positive 5. Add those together, and we'll say 4x is equal to 28. Divide both sides by 4, and we get x is equal to 7. So my answer is x equals 7. Here's our last example. Take a stab at it. If I know it's on the angle bisector, what can I say about KL and ML? Yeah, I can say that they're equal to each other. Okay, and now I'm ready just to do the algebra. So go ahead and combine like terms, solve for x, and tell me what the value of KL is. So hopefully you've got a chance to do that. Here we go. I chose to subtract 2x from both sides, and I was left with 3 is equal to 2x minus 11. And then I needed to add 11 to both sides to bring the 11 over to the left side of the equation. And I was left with 14 equals 2x. And I solved it this way on purpose to show you that you can have the x on the left side or on the right side of the equation instead of the left. It doesn't matter. We can still divide both sides by 2 and get x by itself. And in this case, I have 7 equals x, and that's the same thing as saying x equals 7. Okay, so the value of x is 7, and I'm going to take that, and I'm going to plug it into the equation for KL. Okay, this guy right here. And I'm going to say 2x plus 3, 2 times 7 plus 3, 2 times 7 is 14, plus 3 will give me 17. KL is equal to 17. And I'm done. So those are the kind of the major concepts here today, the perpendicular bisector theorem and the angle bisector theorem. Go ahead and jump over to that Math Excel homework and the lesson quiz. Do your very, very best and bring your questions to your teacher the next time you see them. Thanks, Mustangs. Have a great day.